All right. Well, can everyone see my screen here? I probably need to share it. Hold on for just a second. I'll turn that on. All right. Well, hello, everyone, and welcome to the St. Louis Java Users Group September 2021 edition. For those who don't know, the St. Louis Java Users Group is an informal group of Java developers. Attendance is free. There is no formal membership list. Our normal meeting date is the second Thursday of every month except December, when there is no meeting. When we meet in person, you can join us for food and social at 6 p.m. and the meeting presentation and the announcements and everything will start at 6:30. When we meet in person, our normal meeting location is the Object Computing Incorporated Training Room at 12,140 Woodcrest Executive Drive, Suite 310 in St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Alspaugh, that's me in the middle, Weiqi Gao, and Kathy Zwang. You can reach all of us on the steering committee if you just send an email to that address there at the bottom of your screen. That's javasigsc@ociweb.com. The St. Louis Java Users Group would not be possible without the help of our sponsors. So we have the logos up for some of our sponsors here that have been with us for some time. Object Computing Incorporated is our original founding sponsor. They've been with us since the beginning. And they've filled in so many times whenever we have gaps. Right now they supply the training room when we meet in person. And they've also helped us a lot on the website. JFrog is a more recent sponsor, but they have been sponsoring the Meetup subscription fees. It is free for you to use the Meetup group and RSVP to attend a meeting, but it does cost the Java Users Group some fees to be able to have a site on the Meetup system. And so JFrog is sponsoring that, as well as the Zoom subscription. And that's how we're able to bring this meeting to you over the internet. Signature Consultants and Adaptive Solutions Group are headhunters. When we meet in person, they will often alternate to supply the food. But since we can't deliver that over the internet, we haven't figured out a way to deliver pizza over the internet. That will have to wait until we're back online. But in the meantime, if you are looking for a Java developer or looking to become a Java developer or are looking to hire Java developers, those would be good companies to take a look at and let them know that you found out about them through the Java Users Group. At the end of the meeting, we will have a raffle prize. So sorry if you're watching the recording, you must be present to win, but we'll be raffling 2 JetBrains licenses at the end of the meeting. Elastic also sponsors some gift cards. They're the source of Elasticsearch, if you've heard of them. We're holding on to those and we'll raffle those again once we start meeting in person. Not sure when that will be yet. Intertech is a training company. They supply the famous screaming flying monkeys. What are those? Those are little dolls where if you throw them up against the wall, they scream and they're a lot of fun. But if you go to their website, they have a lot of good training available on a variety of computer-related topics. So I'd encourage people to take a look at it if you're looking to learn a new skill. We will also be raffling at the end of this 2 Manning ebooks supplied by Manning. And Pearson will often sponsor physical books, computer-related books that we raffle at the end. As far as announcements go, we need to remind people that the Gateway Software Symposium, that is the No Fluff, Just Stuff conference, is coming up. That will be October 22nd through the 23rd, 2021. Now there's going to be an option. You can either attend in person or online, either way. It's going to be kind of a dual conference here. For in-person, it'll be at the St. Louis Marriott West at 660 Maryville Center Drive in St. Louis. But this would be an option, like if you're from far away, from outside of St. Louis, you can actually see what's going on there. If you want the details, just go to No Fluff, just to the website at the bottom, nofluffjuststuff.com/St. Louis for all the details. As far as upcoming presentations go, for next month, we have scheduled Jakarta EE, Present and Future by Reza Rahman of Microsoft. And that's going to put us back once again on the Foodj.io virtual jug tour. So they're going to stop here twice here at the jug. And so we'd be delighted to have Reza come and give a presentation here for that next month. So if you want to keep up with our presentations as they are scheduled, just visit our meetup group. That's meetup.com/gatewayjug. And you can see the updates to the presentation schedules and locations as they are posted and updated. Now, if you're interested in giving a presentation or becoming a JUG sponsor, you can email us at that email address that I gave before. That's javasigsc@ociweb.com. So before we get to tonight's presentation, which will be on getting the most from LTS Java by Simon Ritter, I understand that Ari has some announcements from JFrog and maybe some interesting prizes. Ari, you want to take over here?
Sure, Bruce. I really appreciate it. Thank you. I'll go ahead and share, Bruce, if you don't mind. I think you need to stop before I can start. Awesome. Hi, everybody. Let me just pull up my slide. Let's see here. Can everyone see it okay?
Looks good to me.
Awesome. Well, for those of you who do not know me, I'm Ari Waller, and I am the Meetup Event Manager for JFrog, and we are really excited to be sponsors for the St. Louis Jug this year. Always impressed about the speakers and the content that's brought. You can tell a lot of time is being spent by the committee pulling this all together. So great job team in getting that done. I'll just share a little bit about who we are at JFrog. JFrog is the DevOps software company best known for Artifactory, which is considered by many to be that gold standard for managing your artifacts and dependencies. It was also written in Java. I also know that some of you may have heard that JFrog and Docker announced a partnership in the beginning of 2021. And we want your meetup to take advantage of this by taking our Docker challenge. Besides the JFrog t-shirt that you'll be awarded for completing the challenge, it's also a great way for you to try our free cloud version of the JFrog platform. And if you are working with Docker, as I know many of you are, JFrog's cloud subscription is capable of functioning as a pull-through cache for Docker Hub. And because of the partnership I just mentioned, you'll be exempt from their rate limits on pulls from free or anonymous accounts. So that could be pretty valuable for some of you. Now, how do you take advantage of the Docker challenge? Well, that's when the fun comes in. Tonight, JFrog has a raffle just for meetup attendees, and we will be giving you a chance to win a Raspberry Pi 4 desktop kit. This prize has been really popular with the Java meetups recently. There seems to be a big shortage of Raspberry Pi 4s. I'm not sure if many of you realize that as well. I can only order one of these at a time. So they are in short supply, and a lot of people are having a really, really great time with them. So definitely looking forward to giving that away. You can enter by using the QR code or the bit.ly that you see. And I'm also going to drop the link in the chat. And you'll have an opportunity to opt in on that page to receive the Docker challenge as well. So lots of good items for this evening. Really excited about hearing Simon talk. And if I'm going to go ahead and drop that in there, the winner is going to be selected within 2 business days. I wish I could do live drawings. Compliance-wise, I can't. I can only announce a winner's name once they formally accept the prize. So we have a certain period of time for which you can enter, and by the end of this meetup, I will turn the raffle off, and then we will pick a winner within 2 business days, and I will contact them by email, and once they accept the prize, we'll share it with the entire jug in the community, and we can all celebrate with you. And with that, Bruce, I'm going to turn it back over to you.
All right, so at this point, I think we're ready for Simon to give his presentation. Why don't you take it away here, Simon?
Okay, great. Thank you very much. Let me just share my screen. That going, and then slideshow. Okay, and then yep. Hang on. I thought. Sorry, just getting a bit. There we go. Right. Sorry, just a little bit confusing there with the slides. Right. So, yes, good evening, I guess. Yes, good evening. Welcome. What we're going to do today is we are going to talk about OpenJDK 17. But because OpenJDK 17 is the next long-term support release of Java, we're going to talk about everything that has changed since the last long-term support release of Java, which was JDK 11. So there's lots of new features that have been included there. And so as an introduction to that, what we can say is that Java has changed. I think it's fair to say that, and it's changed a lot. And the reason for that is this idea of a 6-month release cadence. This came in JDK 9. JDK 9 was the last major release of Java, as Oracle would describe it. And at that point, they decided that they wanted to move away from 2, 3, or even 4 years between releases of Java to one every 6 months. And I think that we can safely say that that has been a really good decision. What we've seen over the last 3 years or so is that new features are coming through in Java much more quickly than we saw before, and it's allowed us to evolve the platform in a really good way. What that's really resulted in is, incredibly, when JDK 17 comes out next week, we will have had 8 releases since JDK 9. That just seems incredible to me for having spent 25 plus years doing Java. The fact that we've had 8 releases since JDK 9 in this period of 3 years is really quite remarkable. So as I said, more features being delivered faster than ever before. And what we're going to do in this session, as I said, is talk about everything that's been added since JDK 11. So we'll start very logically with JDK 12. And obviously, the reason for this sort of idea is long-term support releases. Now, it's quite important to understand long-term support has nothing to do with OpenJDK. OpenJDK is source code, but there are projects for each of the releases. Long-term support is only provided by the people who do distributions. So Oracle made the decision to have a long-term support release every 3 years. Everybody else who provides distributions, Azure, Red Hat, IBM, and so on, we've all decided to follow the same pattern because it makes a lot of sense, doesn't confuse people. Everybody knows it's JDK 11, then we move to JDK 17, and if you're still using JDK 8, you can continue to get support for that. Now, there's a couple of other things that are sort of a consequence of having this 6-month release cadence is that we can do some other things that we couldn't do before. And one of those is called Incubator Modules. Incubator Modules, defined by JDK Enhancement Proposal, or JEP 11, are about adding features to the Java platform, specifically in the form of non-final APIs and non-final tools. And it's that non-final bit that's quite important. What the idea behind Incubator Modules is to add new library code or potentially tools, which is fully formed. It's not like a beta, it's not like in development. This is something that has been completed, but rather than making it part of the standard straight away, the developers want to let the developers use that API or tool and then solicit feedback, find out whether it really does exactly what people want it to do. And then if changes are needed, they can do that before it becomes set in stone as part of the standard. Potentially with Incubator Modules, if people really didn't like an API or a tool, they could withdraw it completely. I don't think that would happen, but it's potentially something that could happen. If you look back to JDK 9, which is really when these things were introduced, we had the first Incubator module, which was for HTTP2 support, and that became final in JDK 11. I don't actually think there were any changes between 9 and 11, but it was just to let people play with it, find out what they thought of it, and so on. The other thing that is very similar to that, but not for APIs and tools, is the idea of preview features. And we're going to see a lot of these as we go through the presentation, because really pretty much any language feature that's introduced, certainly since JDK 12, is a preview feature initially. And then after feedback's been given, then we put it into the standard and make it a final feature. This is all about things which relate to the JVM or to Java SE. And that's the thing that's specified through the Java community process. You have your Java specification request. So anything that would be an effect on the standard itself is covered by a preview feature rather than incubator module. So that's the sort of distinction between those. Again, it's the idea of having a fully formed feature, allowing people to provide feedback, and then if you want to, making changes. With these, you do have to specifically enable them. With incubator modules, all you do is you just bring the module in on your module path and it will work without any problem. But because these are language features and they are ones which are not part of the Java SE standard at that point, you need to tell the compiler and you need to tell the JVM that you want to use these things. So you need to enable them. To do that, you use the enable preview flag. So when you compile, you say enable preview, but you also need to tell the compiler which version of the preview features you want to enable. So you need the release flag as well. You'd say release 17 or release 16 or whatever, and you would enable the features for that. When you run your application, you don't need the release flag because that's already kind of baked into the jar file or the class file. So all you need to do is tell the JVM, yes, I do want to use those preview features, so allow things to run which are not part of the Java SE standard at that point. So we still maintain that write once, run anywhere compatibility. Yeah, there's just one other minor point about that, which is that sometimes you do find that there are APIs that creep into preview features, and that's where the APIs are specifically part of the Java SE standard. So anything that's in the Java or JavaX namespace could creep into the preview features, even though you would think it would be in the incubator modules. Right, so let's talk JDK 12 as the first release since 11, which was their last long-term support release. What did we get here? Well, we got switch expressions as a preview feature. Now, the thing about switch expressions is that in Java, right from the very beginning, we've had the idea of a switch statement. And a switch statement, everybody here programs in Java, so you know what it is. It's really a sort of multiple conditional statement. So it's rather than doing if, else, else if sort of thing. What you do is you do a switch statement and you have a number of cases which determine what you want to do with that. Now, that's all very good. But there are some sort of drawbacks that can catch out people in terms of the ability to write simple code and the ability to write reliable code. The syntax of the switch statement can be a little bit clunky at times. The reason for that is really because if you look at the history of it, it goes back to the C programming language, which is where it came from originally. Now, C as a programming language is designed more for systems, so operating systems, compilers, and things like that. And if you look at the way that the switch statement works, you have this idea that multiple cases, and where you put the code that you want dealt with in that case, then you also have to remember to put a break to drop out so that you don't fall through to the next set of case statements. That's the way it works. So you always have to remember to put the break statement in unless you really do want something to drop through, which is pretty rare. I mean, I think I've used that maybe once or twice when I was doing C code. I've never used it in Java. Problem is, if you forget to put the break statement in, then you do drop through to the next set of case statements, and you can end up with a bug which could be very difficult to figure out because you go, well, hang on, I shouldn't be doing that piece of code. How am I possibly getting there? The other thing that the case with the switch statement is that sometimes the scope of local variables can be not so intuitive as you might think. Now, if we look at an example of how we would use the switch statement in the past, this is a very common sort of pattern when we use it. What we're doing is we're saying, I want to switch on one particular value, And then based on the value of, in this case, day, I want to assign something to another variable. So the number of letters. Very simple example. So I switch on day, and then case Monday, case Friday, case Sunday. I assign number of letters to be 6. Case Tuesday, number of letters is 7, and so on. As I say, if we look at that, we can see that we have to remember to put that break statement in for each of the set of case statements. And the other thing that can be a little bit tricky is that we have to remember, as a developer, to always assign a value to number of letters. And we have to do that for each of our set of case statements. If we forget to do that, again, we can get a subtle bug where it might be difficult to kind of figure it out and go, well, hang on, why am I not getting the value that I expect from that? So in JDK 12, we now have the idea of the switch expression. And obviously, there is a difference between a statement and an expression. Statement is a piece of code that executes, but it doesn't return a result. In the case of an expression, it's a piece of code that executes, but does return a result. Having returned that result, we can assign that to a variable and make an assignment. If we look at this piece of code here, what we can see is that our code from the previous slide has become a lot simpler, a lot less lines of code. Breaking that down, first thing is that now that we have an expression, we make the assignment to number of letters once. And the good thing about that is we don't then have to remember to do that assignment in other places. So we do the assignment once, we eliminate that potential for error there. Then we've got the idea of our case statements. And one of the things which I find really quite remarkable is it's taken the developers of Java over 25 years to figure out that there is this thing called a comma separated list. Rather than having case Monday, case Friday, case Sunday, we can all put it on one line and go case Monday, comma, Friday, comma, Sunday. Unbelievable. Really, that is one of the biggest advantages of this. What we've then done is borrow some of the syntax from lambda expression and use the arrow operator. And the right-hand side of the arrow operator is the value that will be returned from the switch expression. Or in the case of the default, we can see there we could throw an exception if we needed to. So that's still quite possible. This is now much more succinct, as in it's less lines of code, less error prone, but we haven't lost any of the readability. If anything, it becomes easier to read now. So that's one of the sort of goals of a lot of the changes that are being made to Java, is to make the code more readable, more easy to understand, and not lose any of that readability. Now, one of the things that the developer said is, okay, let's combine the idea of the old style syntax with the new style syntax. So we can still have a switch expression, but we can use the switch statement syntax in the way we did before. Kind of makes it easier to make the migration. In this case, again, we're making our assignment, but rather than using all of the cases on one line, we can separate them out and have the colon rather than the comma. And in terms of the value that's going to be returned from the expression, rather than using the arrow operator, which would be difficult to parse in this case, they decided to use the break keyword and then have a value after that, which is what's returned from the expression. Now, in this case, this is one of those situations where there's a little bit of overloading of syntax, because you could potentially have a break with a label. And if you're in a loop, you can break from within the loop to outside of the loop to a label in your code. Now, in the case of what we have here, there is no ambiguity because a label cannot start with a number. So the compiler will know that where it sees break 6, that's the return from the switch expression. If you had break label, then it would go, okay, that's a break to outside of the loop to the label. JDK 13. So JDK 12 didn't have that much in terms of new language features. There are a couple of API changes as well, but because of the amount of time I've got, I'm not going to go to every single feature. JDK 13. In this one, we got yet another preview feature. This time it was text blocks. And the developers of Java have kind of had a couple of attempts at coming up with an idea of how to do multi-line strings in Java. It's always been a bit of a problem. Right from the very beginning, obviously, we've had string literals in Java, where we can assign a value to a string variable, and we can say double quotes, our string, double quotes, great. But the problem comes if you want to put special characters in there, you need to use escape characters. And if you want to have that include line breaks, then you either have to concatenate lines, concatenate strings, or do something a little bit more sort of fiddly. What we now have is the idea of a text block. As we can see, rather than using a single double quote to start the string and end the string, what we use is the same as Python. So we borrowed some syntax there from the Python language, and we use 3 double quotes to indicate the start of a text block. Everything after that will be considered part of the string literal up to the next 3 double quotes. If you wanted to put 3 double quotes into your string, which you might want to do, then you would have to escape at least the first one of those double quotes. You'd have to have a backslash in front of at least the first one. You can actually put backslash in front of the first, second, and the third, or the first and the second, but you must have a backslash in front of at least the first one. Okay, now there's a few details about this that we need to be aware of. If we run that piece of code and we print out what the result is, we will see this. And we will see that we got our HTML tags, and we've maintained the indentation of those tags as we have in the code above. But what we don't see is those tags having a lot of padding on the left-hand side. So the first tag is justified against the left-hand margin. That makes a lot of sense because that's really what we want to achieve with the tags that we have above. But rather than forcing the developer to push all of the text over to the left-hand margin in the code, which would make it less readable, what we do is we say, okay, well, you need to line it up so it fits in with the string web page part, and we'll ignore some of the white space. How we do that is through the idea of incidental white space. So incidental white space is essentially all the white space up to the first character that we have in terms of our text. Any other white space beyond that, where we've got the indentation of the tags, will be maintained. So we're not sort of stripping out all white space. We're only stripping out the white space that's relevant to the source code layout that we have. Now, a couple of other things about that is that the opening 3 double quotes actually is opening 3 double quotes plus a new line. So you cannot put the start of your string directly after the 3 double quotes. You must have a new line, and then we can see where the incidental white space comes in. Another thing that's quite important is that if you put any trailing spaces after the text, and that's on any of those lines, then it will be stripped out. I don't quite know why they decided to do that, but that's the way that it works. So if you have your closing HTML tag there and you've got 4 spaces after it, if you looked at what was actually printed out, although it's not easy to see on the slide, there would be no spaces after that closing HTML tag. That would be stripped out. Now, if we do want some additional indentation for our tags, so let's say we need 4 spaces of left justification, then we can do that by moving the closing 3 double quotes. If we shift those over to the left, then what we're introducing is intentional indentation. So we can add 4 spaces of intentional indentation, and then we can still have a certain amount of incidental white space that will be stripped out. But clearly, we're only removing a certain amount of incidental white space and allowing things to be printed out. And if we show the result of that, what we'll see is our HTML tags are now indented correctly, plus shifted over to the right by the number of characters that we want for our intentional indentation. One minor glitch of that is that in order to do that, we need to drop the 3 double quotes for the closing part onto the next line so we can show where we want the intentional indentation to go. The result of that is that we get an extra blank line, which we might not want. So I'll come back to that later. Switch expression. Hang on, I've already talked about switch expression. Why am I talking about switch expression again? Well, this is an excellent example of how preview features work, and the fact that we can have feedback and we can make changes to the feature before it becomes final. When it was proposed to have switch expressions using the old style syntax of the switch statement and using break to indicate what the value to be returned from the expression was, people said, yeah, okay, you can do it. You can parse it with the compiler, but it's a bit confusing. So, you know, am I breaking to a number? Am I breaking to a label? Wouldn't it be better if we use something else? And the developers looked at that and they said, you know what, that's fair comment. You're right. We're going to do something different. And they changed, in this particular case, rather than using break, they would use yield. So it's just a different keyword. And now it does make it clearer. If you were to have a situation where you had a break to a label, you could see, okay, that's a break to a label, and yield is being used to show what's being returned. So just eliminates a little bit of confusion that might creep in some very unusual circumstances. Jdk 14. This was one of those releases that had quite a lot of new features in that are really quite powerful. So we've seen a sort of gradual thing with 12 and 13. Now with 14, we're sort of seeing some of the really valuable things that are in this LTS release when we get to Jdk 17. In Java, we often use simple data classes. And in this case, what I've got is essentially a tuple. So I've got a point class, which is going to contain two values, X and Y, both of which are doubles. Right, so that's easy enough. I can create a class, I can call it point, I can then have two instance variables, double X, double Y. I can create a constructor, which takes two variables, double X, double Y. I then assign those to the instance variables. I've got two accessor methods to return the value of X and the value of Y. Great, it's very easy code, nothing really dramatic about that. But it's 14 lines of code just to create a tuple. And if you're in a situation where you need lots of different sort of small data classes, you end up with a lot of proliferation of classes and what you might call type pollution in your application, making it harder to maintain and so on. So in Jdk 14, we now have the idea of records. And once again, it's a preview feature. Records are essentially a data class that provides you with all the functionality you had in the previous class, but without having to put all of that boilerplate code in there. Previous slide, 14 lines of code. If we now turn that into a record, it's one line of code. All we need to do is use the record keyword to indicate that our point is going to be a record. And we use the same syntax as the constructor to show that the values that we want to store in this record are going to be a double X and a double Y. We have an empty set of braces after that because a record is a form of class. It's a special form of class in the same way that enumeration is a special form of class. So there is a body associated with it. And in this case, we can have a single line and then we can use that, and it just makes life a whole lot simpler in terms of not having to do all that boilerplate code. Now, there are lots of other things we can do with records. First of which is we can make them generic. Like I said, they are a class, so classes can be generic. We could introduce a generic type parameter, and we could have a record called anything with a type parameter T, and then we can say that what we want to store in that is an object of type T. And then however you define your record, when you create a record, whatever you put in there, a string or an integer or whatever, that's what's going to be stored there. So it will work quite happily with generics. The other thing is that there are restrictions on what you can do. So you specify through the definition of the record what values you want to be stored in the record. In the case of our point, it's X and Y. In the case of anything, it's T. What you can't do is add extra instance fields to your record in the body of it, unless they're static. In this case, I've got a record which is going to be a circle. It has one value that we want to store in there, the radius, but I want to have a static value to be pi, so that if I want to calculate the area of it, I can use that static variable and manipulate it in the way that I need to. And I haven't fixed the error in this, because of course it's pi r squared, not pi r. Must remember to change that. But anyway, so you can see that you can introduce a static instance field, but not one that's a class-specific instance field. A few additional details about records. As I said, they are a special form of class, and one of the things about them is that they all have a superclass, which is java.lang.record. What that means is that a record cannot subclass any other class because it already subclasses record. Therefore, you can't subclass another one. But you can implement as many interfaces as you want. That's not a problem. So you can have interfaces associated with the record and implement the necessary methods for that. Because a record is a class, you can, if you want to, override the equals, hashcode, or toString methods of the object class. If you want to have the way that the equals method works different, then you can do that. If you want to have a different hash code generated, if you want to produce a different string for representing your record, all of that can be done without any problem. Records are implicitly final, meaning that not only can you not inherit a record from another class, you can't subclass a record with another class. So it's implicitly final. If you really wanted to, you could add the final modifier to your record, but you don't have to, and I don't think anybody would. Interesting one here. Records do not follow the Java bean pattern. This generated a lot of discussion on the mailing list when they were creating the idea of records, and the decision was made that rather than using the bean pattern idea of accessor methods where you'd use get followed by the name of the variable, they would just use the name of the variable as the method name. In the case of our point, you use x as a method to retrieve the value of x rather than get x. That's all well and good, and it's one of those things that is most of the time is just a sort of personal choice on the point of developers. But there are certain situations where some libraries rely on the bean pattern, and so if you start using records with those, then you can run into problems with it not having the right accessor methods. So there's a couple of things about that. One is most of the libraries that were doing that, now that they want to be able to support records, they're seeing that in JDK 14 they can't use that pattern anymore, so they will, for records, support the idea of the named accessor method rather than the get thing. But as somebody pointed out to me, which I thought was quite funny, you can get around this, because rather than calling your value x, you call your value get x or get y, and that way you will still have the accessor method called get x and get y. It will work, and it's a little bit kind of kludgy, but it's a way around the problem. Constructors are quite an important thing in records. Now, in the example that we saw before, we didn't have a constructor. So we just assumed that a constructor would be created for us, and it would take, in the case of point, x and y, and it would make the assignments to our instance variables. We can have what's called a canonical constructor. So in this case, what we're doing is we're saying, okay, we've got a record which is called trex, and it takes int x and int y. And then we can, if we want to, create the constructor, and we can specify it in the same way that we would do before. So we'd have public trex, int x, int y, and then we can put in some additional logic to say if x is less than y, print out a message. We then explicitly have to put in the code to say assign x to this.x and y to this.y. In this case, we're starting to lose some of the value of the records because we're going back to putting in some of the boilerplate code that we had before. To get around that, what the developers of records did was they said, okay, rather than just the canonical constructor, we'll also allow you to use a compact constructor. So a compact constructor does essentially the same thing as the canonical constructor, except that we don't have to have all of the boilerplate code. So now we can say we have a record called range that has low and high as its values. We will specify a compact constructor, which doesn't need the parameters because we know what those are from the definition of the record itself. So let's avoid that. And then we can include the additional logic we need to test if low is greater than high. We don't then also need to make the explicit assignments of low to this.low and high to this.high. So the compiler will do that for us. So compact constructor is a nice sort of way of doing things if you need that little bit of extra logic, but you don't want to have to get into all of the boilerplate code that you would with the canonical constructor. One thing about the compact constructor, and in fact also about the canonical constructor, is you cannot throw a checked exception. In the example of my range, I'm throwing in a legal argument exception, which I can do because it's an unchecked exception. If I the format of the, or the syntax of the both compact constructor and the canonical constructor is that there are no you cannot specify a throws clause associated with it, which is a little bit odd because in the case of the canonical constructor, you might think that that would be logical to be able to do that, but you can't. Now, if you want to, you can create a standard constructor, and that would be one that is different to the canonical constructor. In that case, you can throw a checked exception. So if you really wanted to do that, there is a way, kind of a way around doing it. In this case, what I've done is I've said, okay, let's change the signature of the constructor so that it doesn't have the same as the canonical constructor. I've added an extra variable Z, which I don't use. And that way I can then throw a checked exception because I can define that in the throws clause. What I do have to do, though, is I have to call the default constructor or the canonical constructor by doing this x, y. And they have to do that if you're going to store values in your record. So the important thing about this is that constructor signature must be different to the canonical one. And then the last thing to say about the constructors on records is that you can have a default constructor. So no argument constructor. And if you really wanted to, you could have no argument constructor that would populate your record with values by calling this with fixed values. And you could do that. So it's probably something that you wouldn't do very much, but it is possible to do that. Next thing in JDK 14 is related to the instance of operator. Again, this is something that's been in Java right from the very beginning. Java's object-oriented, and we may have a situation where a method gets passed a reference to an object, but we don't know the specific type of that object. We know it's superclass, but we don't know which specific subclass it is. What we then do is we need to do a test, and we say, in this example, if obj instance of string, then we want to do something with it. In order to do something with that obj as a string, what we have to do is create a variable string s, and then we have to do an assignment to that with an explicit cast. Just standard Java, we've all done it, but it has to be done every single time. And there really isn't many situations where if you did a test of obj being instance of string, you wouldn't immediately do that assignment with the explicit cast afterwards. Having done that, you can then reference s as a string because it is a string and use the methods on it, and that will all work quite happily. In JDK 14, we have yet another preview feature, which is called pattern matching instance of. Now, pattern matching in this case is not to do with regular expressions. It's to do with pattern matching of types. So what we're doing here is we're saying, okay, well, let's look for a pattern in terms of the type, and then we'll do something with it by assigning a value. As we can see here, there's a small change to the syntax, which is quite helpful. We say if obj instance of string, but then we immediately say what the variable is that we want to use to reference that obj as a string. So we don't then have to have the line that we had before where we do the explicit cast. It's all taken care of for us by the compiler. In terms of the scope of our variable s, within the true branch of that if statement, clearly we've passed the test of obj being a string, so s is valid and we can reference it and we can use it as a string. In the else branch, because we failed that test, s is not assigned, it's not cast to obj, and so we can't use s. The scope of s is not valid at that point. We can be a little more clever with this, and so we can actually do things. This is essentially a guarded pattern match, where what we're saying is if obj instance of string s, and then we use the and operator, we say s.length is greater than 0. Now we can do that very logically because we know that the way that the and operator in Java works is that we always evaluate the left-hand side of the operator, and only if that equates to true do we bother doing the test on the right-hand side. So sort of short circuit to avoid having to do tests unnecessarily. Because we know that in order to go to the right-hand side of the operator, the left-hand side has to be true. So obj would be an instance of string. And so S, the scope of it, would be valid on the right-hand side of the AND operator because it is a string. What we then do is we say, okay, we can call length on S, test it against 0. And if that is the case, we will then go into the true branch of the if statement, and we can then print out what the length is. Obviously, we can't do that if we use the OR operator, because that would give us compiler error, problem being that we would have to evaluate the left-hand side, and only if that equates to false do we then go and evaluate the right-hand side. So if it's evaluated to false and then we try and use S, we know it's not going to be a string. The compiler will go, it's not going to work. So it will reject it at compile time, not runtime. And last thing to say about the scoping of variables that are used in pattern matching is it uses what's called flow scoping. So sometimes the effect can be a little bit less than obvious, shall we say. In this case, what we're doing is we're saying, if O is an instance of type string, and then we invert that. So we're saying if it's not an instance of string, then we return. Having done that, afterwards, we know that what we actually have is, in the case of O, it is a string. So the scope of S is then valid after the if statement. So everything up until the end of the method that we're in will have S as valid scope, and it will be able to use as a string. Text blocks. So again, being a preview feature, feedback was provided. The developers said, yep, there's a couple of minor changes that we'll make there. What they did was they introduced 2 new escape sequences within text blocks. First of those will be familiar to people who've done things like shell programming or make files, where you use a backslash to indicate that you want continuation onto the text of the following line without a line break. So in the case here, we got this line will not contain a new line in the middle. That'll all be on one line. Then you'll have a line break, and it solves the extra blank line issue, because if we put the backslash at the end of our final line, the fact that we then go on to a new line, we won't get that. So we won't get that extra blank line that we saw in the first example that we saw earlier, which is good because that solves that problem. Other thing they did was they said, having decided to strip trailing spaces, we now need to allow people to put them back in again if they want them to be there. So to do that, they would use the \s as an escape sequence to indicate that any white space to the left of that \s would be kept in the text block. So it's, again, just solving that problem of not stripping out spaces where you might want them. Helpful null pointer exceptions. This is not a language feature. This is related to the JVM. Who's never had a null pointer exception? Yes, we all have. I mean, it's just such an easy thing to do when you're developing code in Java. Most of the time, it's very straightforward. You just look at the line that generated the error and you go, okay, I know what I did wrong. I didn't assign something, so I'll fix that. But the tricky bit comes when you do something like this. So you've chained together a number of references, and you've got a.b.c.i equals 99. When you run your code, you get a message like this, which says exception in thread main, null pointer exception on line 5. Great. So now I know where the line is that generated that exception. But what I don't know is the fact that A was null, so I couldn't reference B. Was it B that was null, so I couldn't reference C? Was it C that was null, I couldn't reference I? And then you get into, okay, I need to use the debugger. I need to go into the code and maybe separate out the way that I've chained together the references, put in print statements or things like that. So it gets all very, very messy. Now in JDK 14, we get this. So we say null pointer exception cannot read field C because a.b is null. Immediately I know what the problem is. Okay, trace back to where did a.b come from, and why have I not assigned a value that I can then reference to C from? And great, it just makes life easy. It makes life easy, except for some bizarre reason, the developers of this feature decided to force you to enable it with a command line flag. The command line flag is -XX show code details in exception messages. Could they have made that any longer? I mean, I'm sure they could, but I mean, that's a pretty long flag. I'm sure they could have made it shorter than that. And I really don't know why they decided to have a flag to enable it, and you have to enable it it's not enabled by default. I guess the only thing I can think of is if somebody was parsing error messages that came from an application and they weren't expecting to see this extra line in there, then that would be a problem. But surely it would have been better to turn it on by default and then allow people to turn it off if they're parsing error messages. But anyway, I'm sure there's some logic in there somewhere. Moving on, JDK 15. Right. Java is an object-oriented language, and we have inheritance. So we can have a type hierarchy like this. We have a class called shape, and then we have 3 subclasses, triangle, square, and pentagon. This is all very good, but we don't have any real control over who can subclass our classes. It's a sort of all or nothing approach, because if we wanted to, we can make a class final, meaning that nobody can subclass it. So it's either anybody can subclass it or nobody can subclass it, but there's no fine granularity of control over this kind of thing. In JDK 15, we introduced the idea of sealed classes, which again is a preview feature. In this case, what we're allowing the syntax of the code to do is to specify that we have control over which classes are allowed to subclass a particular class. And anybody who's not on that list will be rejected by the compiler. One of the interesting things about this is that when I looked at this, I read the spec and it said this also applies to interfaces. I thought to myself, I wonder why they didn't call it sealed types, because that would have made more sense to me. But then I posted a tweet about that, and I think it was David Delabas from Oracle came back and he pointed me to a reference to this. And it turns out something I learned new, an interface is actually a form of class. So they decided to call it sealed classes rather than sealed types. Just a minor thing about the Java language. Now, the way this works is it uses some contextual keywords. This is actually quite an important thing because what they've done in Java is they've kind of added more features. And sometimes you might think, oh, is that introducing a new keyword, which could have a big impact in terms of backwards compatibility, because any new keyword would prevent you from using that as a variable name. If we look back at the history of Java, and you go all the way back to 1.4, the introduction of assertions introduced a new keyword, assert. So any code that used assert as a variable name had to be changed in order to recompile on 1.4. On JDK 5, we had the introduction of enumerations, and enum became a keyword. So that broke backwards compatibility if you used enum as a variable name. Since then, we've done a very good job, and we've used the idea of where a keyword is being used to parse it correctly and not having to worry about setting hard keywords. So a lot of the things that we've seen already work, like record, for example, is a good thing, where we don't have to worry about record becoming a reserved word and not being able to use record as a variable name. Anyway, so what they now have is this idea of contextual keywords, which replaced things that they had before, which was restricted identifiers and restricted keywords. So var was an example of those types of things. One of the things with sealed classes is that they all have to be reasonably local. So they have to either be in the same package or in the same module. You can't have them spread out in other modules or other packages. The way this works is it slightly changes the way that we can define a class. So what we now do is we say, in the case of our shape class, we've got our class shape, but we add a modifier to say that this is a sealed class shape. And then we add a permits clause to indicate which classes are allowed to subclass shape. In this case, triangle, square, and pentagon. That tells the compiler that there are 3 classes that can subclass shape. And then if somebody comes along and says, oh, I like shape, I think I want to create a new one called circle, that won't work. The compiler will reject that if you try and extend shape, because it's not in the list of permitted classes for shape, and so it gets rejected. The idea behind this is that if you've got, sort of big project where you've defined some classes, and then somebody else in another part of the project comes along and says, oh, actually, I like that class you've got there, I'm going to inherit from it and use that for my code. That sort of works very nicely. That's the whole idea of object-oriented programming. But if you then come along and say, okay, I'm going to make some changes to my class, it may be that the person who's depending on it doesn't know about that. And so you can run into problems of the functionality changing in your code. Suddenly it changes the way that somebody else's code works, and they don't realize that it's because you changed your class. So by sealing a class, you protect your code from other people doing that. And if somebody wants to use it, then you can put it in your permits clause, as long as they have the right access and so on. And then it allows you to sort of know that if you make some changes to that, you've got to then go and find that person and go, hang on, I've changed shape, so your circle class now has to do something different. In terms of the way that the subclasses work, all subclasses of a sealed class must specify their inheritance capabilities explicitly. And there are 3 different ways of doing that. First of those is you can continue to make that class sealed. In the case of our triangle, what we can do is we can say sealed class triangle permits equilateral and isosceles. So our type hierarchy extends further, but we're still maintaining that sealing of the class. The second thing we could do is we could stop any further subclassing of that class. So we make it final, and then it just turns off the ability to subclass it, exactly as we have used in the past. And then the third way of doing things is using a keyword which is non-sealed. So now the idea is to say, in the case of our pentagon, we want to make it open so anybody can subclass from it. So we use public and we use non-sealed as a modifier, class pentagon extends shape. Using hyphenated keywords or modifiers is an interesting thing. Again, it caused a lot of discussion on the mailing lists about whether we should be doing hyphenated keywords. But the idea is that if we're going to extend the language further and further, we want to do hyphenated keywords because it just gives us more capability in terms of what we can do in that sort of way. And since variable names cannot use a hyphen in Java, then it doesn't run into any problems of backwards compatibility. Records. Second preview. In this case, they said, again, took some feedback, had to think about things, and they decided they make a couple of changes. First thing they did was to say that the fields in a record are now truly, really final. You might think that because you apply the final modifier to a variable, having set its value once, you can't then change it. Well, that's certainly true in terms of the code that you write, but it's not true in terms of being able to use reflection. So if you use reflection, you can actually take a final variable and you can change its value through reflection. In the case of records, they've stopped that. So if you even try and use reflection to do it, it'll throw an illegal access exception. Great. So that solves like the idea of making records truly immutable. The other thing actually to mention about records being immutable is that it's shallow immutability. Obviously, if you have an object reference as the value that you're storing in your record, that object could contain multiple different values, and there's no immutability unless you enforce that within your class. So it's shallow immutability. Only the references to the things that are stored in the record are immutable. Or I should really say unmodifiable, I guess. The other thing they decided to do at this point was to ban native methods from a record. Like I said, it's a class, so if you wanted to, you could include a native method. Previously, they decided that since that could introduce behavior that was dependent on external state, which they didn't really want to do, then they simply said prohibit native methods. The other thing that they did in Jdk 15, yeah, Jdk 15, is it 14, 15? 15. I always get lost about this point as whether I'm talking about 15 or 14 or 16, is they introduced the idea of local records. So this is really good because it also now extends to enumerations and interfaces. You couldn't use those within a method directly before as local references. But now that they've done it for records, they've also made it applicable to both enumerations and interfaces. What this means is that you can do something like this. Rather than having to specify the record outside of the method and make it available, to the rest of the code, you might have situations where you just want to use a record within a particular piece of code and then you don't care about it. Here we've got a method called find top sellers. And what I'm looking to do here is to take a list of people selling things for me and a particular month. And what I want to do is order those people selling based on how much they have sold. So most sold to least sold. Now, to do that, obviously I can write code and I can use some streams and do all that. It will work. But to simplify it, I'll use a local record, create that record, which is called sales, and that will have two values in it. One is the seller that I'm interested in, and the second value is going to be how much they sold in a particular month. Then what I can do is I can take the stream from my list of sellers, pass that into map. So I map my seller objects into my records using the seller that I've got in my input stream, using a method to take that seller and calculate how much they sold in the month that I'm interested in, populate my record, so I get a stream of records, pass that into sorted, and use the values associated with each seller to order it based on how much they sold. So now I've got an ordered stream of records that have sellers and amounts in them. Pass that through map again, so I map it back from the sales record into the individual sellers. So I extract those out. So now I'm not dealing with records, I'm simply dealing with the stream of sellers that I had before, but they're ordered, collect that into a list, and that's my result. So it's nice, neat code. I really like this. This is a great way of using records. The other thing in terms of the second preview is that records will work with sealed classes, and more specifically interfaces. It has to be interfaces in this case. So I could create a sealed interface called car, permits to other interfaces, red car and blue car. And then in terms of my records, although I can't extend another class, I can implement an interface, and so I can implement car from both red car and blue car. JDK 16, yes, I was on JDK 15, I thought I was. JDK 16. Pattern matching of instance of. So as I said, that was something we talked about in JDK 14. What they did here was they said, right, now we're going to make pattern matching instance of final. So we've taken feedback, we've decided what to do, now it's a final feature. A couple of minor changes that they made, again, based on feedback. First was that the pattern variables are no longer explicitly final. So the S in the case of our string is no longer explicitly final. That I think is useful because you may want to change what that thing refers to, and you can now do that. The other thing they said is it's a compile time error to compare an expression of type S against a pattern of type T, where S is a subtype of T. You have to read that a couple of times to figure out what it actually means. But essentially, if I show you an example, if I had something like this, I've got a method called printColoredPoint. It takes a rectangle as a parameter, and then I do if R instance of rectangle, and then I want to assign it to rect. Well, that doesn't make any sense because I know that what I'm passing in is a rectangle. So it's a redundant test because it's always going to be true. Now the compiler will reject that. So it will say, nope, you can't do that because rectangle is a subtype of rectangle. Well, yes, it is. So that doesn't make any sense. So it eliminates the code. Stream to list. This is just one of those small API changes that I thought I'd include in the presentation because it's one of those things that's just like really helpful. It's essentially a simplified terminal operation which avoids explicit use of collect. We have a terminal operation in the streams API, which is to collect the elements of the input stream into something. And quite often what you want to do is collect it into a list. To do that, what you would do is you would say, okay, take stream of 123 and collect it using the collectors utility class to list method, and it will generate a list with 123 in it. Now there is a specific terminal operation which just eliminates the fact you have to use collectors and then to list, and you just say to list. Okay, great. Small change, but one of those things that I think is really kind of handy. Another one that's just a very minor thing that I came across when I was looking at what was in JDK 16. There wasn't much in way of language changes for JDK 16, so I kind of picked up a couple of API changes here. Period of day. In the sort of date and time API that we have now, you can say in terms of creating the string that represents what time of day it is, you can specify whether it's AM or PM. So obviously before midday, after midday. Now we have a more descriptive way of doing that. So we have the idea you can do date time formatter of pattern, and they use capital B. Clearly, they ran out of letters, and that was one of the letters that they found that wasn't in use because it doesn't really have anything to do with period of day. But anyway, so you use pattern B, and then you format local time now, and what you would see is something like this: in the afternoon, in the evening, at night, in the morning. So it's a more descriptive way of specifying what time of day it is. Vector API. So this was an interesting one. This was introduced in JDK 16 as an incubator module. So again, rather than being a preview feature, it's a set of APIs which are subject to change before they become part of the standard. Now, first thing, this is not to be confused with the vector class that we've had, from really right back to, was it maybe JDK 1.2, or even before that. But anyway, so not to be confused with the vector class. It is a vector API. So what does vector API do? Well, it allows you to express vector computations. And this is really the kind of thing where if you've got numerically intensive operations and you're doing the same thing to lots of values, this can be very good in terms of improving performance. So you can compile your code to optimize based on the hardware that you're actually running on at the time you run your application. So although the code will generate bytecodes, when it gets converted into the native instructions by the JIT compiler can do more in terms of optimizing. Ideally, this would not be necessary. If the compiler was smart enough, it would spot the places where vector operations could be used and you wouldn't have to do the manual labor yourself. At some point, this should happen. I can say that with some level of confidence because if I look at what we do at Azul with our prime JVM, which used to be called Zing, we have a different JIT compiler called Falcon based on the LLVM project, and that will recognize lots of places where vector operations can be used. So you wouldn't need to use the vector API as much on prime as you do on hotspot. Now, the way this works is that, as I said, if you've got an array of numbers and you want to perform an operation on each of those numbers, let's say you want to add 2 to each of them, then what you have to do is create a loop, and you have to go through and you say, okay, add 2 to my first number, go through the next iteration of the loop, add 2 to that number, next iteration, great. But obviously it's a repetitive thing, have to be done the number of times that we have elements in our array. With using vector operations, this is the idea of single instruction, multiple data. And what we do is we use a very wide register. We lay out the elements of our array into those very wide registers. And rather than having to do one at a time, we can say, okay, call it's actually an AVX instruction on the Intel processor, and add 2 to each of the elements contained in that very wide register, and do it so that we can, in a single instruction cycle, we can do, in this case, 4 elements at the same time. Now, if we look at a simple code example of this, what we've got here is a situation where we've got 2 integer arrays. And what we're doing is we're saying we want to add the value of the second array to the first array, but only if we've got an even value in the second array. I don't know why you would do that, but that's what we're doing. Now, the important thing about this is by having a conditional operation there, the if bi ANDed with OX1 equals 0, that makes it very difficult for the compiler to recognize as a vector operation. Like I say, Falcon, our JIT compiler, will recognize this, but Hotspot won't. What we can do then, we can look at the code that's generated without using the vector API. And don't worry about all the instructions here. The important thing here is the red boxes. The red boxes show the loop that we've got there. And essentially, the only optimization that the C2 JIT compiler is able to do is to do a little bit of loop unrolling. Rather than doing each element with a separate iteration of the loop, it'll say, okay, let's do 2 elements each time and halve the number of iterations we have to do. So it's a common technique, but doesn't really do much for improving performance. If we look at using the vector API, then our code gets a bit more complicated. We have to do a little bit more work to set this up. What we do here is we say, okay, we need what's called a vector species. And the vector species is essentially saying that we need a wide register and we need to tell the system what we're going to store in that wide register. So here we're using a 256-bit wide register, meaning we're using AVX2, and we want to store integer values into that 32 bits. Then what we do is we take our loop, and again, we do our conditional test on whether we want to do the work. Then what we need to do is we need to create a mask. The mask allows us to essentially populate the elements into that very wide register, and the mask sets up where the bits are going to be put in the register. Then we create vectors for both the elements from the A array, that's the word I'm looking for, array, elements from the A array and the elements from the B array, and then we say what we want to do with those elements. So in this case, we've got vector A being added to vector B, or vector B added to vector A, I should say. So we've got the elements in our array, in our very wide register. We then perform that operation on them. We take the results of that, and then we have to sort of extract the values out of the register and put them back into the array that we want to have them stored in. So that they go back into A, essentially. If we look at that code generated by the compiler, what we'll see is it looks more complicated for our loop. But what's happening here is we are actually using the vector operation. As I said, on this machine, it's AVX2, and it's doing loop unrolling as well, plus the vector instruction. So we were getting 4 elements per iteration of, 4 elements per operation on the very wide register. To, is it 4 or is it 8? 256, yeah, it's 8 elements per iteration. So it's much more efficient in terms of parallelizing the operation. Jdk 17, bring us right up to date as of next week. Pattern matching for switch. So we looked at pattern matching for instanceof, where we said that we were looking for a type pattern, and then we wanted to do something by assigning it to a variable. The problem, if you like, with switch is that it's limited in terms of what you can switch on. Basically, you can use integral values, you can use strings, and more recently, you can now switch on enumerations. But you can't switch on other things. What pattern matching for switch does is extend that, so you can now match on, you can now switch on a type as well as those other things. And if we look at an example of that, what we'll see here is we've got a switch on object O, and then the cases are going to be, well, case null. So if it's a null, we'll do something, we'll print out as a null type. If it's a string, then we print out the string and the value. If it's a color, we print out the color with the RGB values. If it's an array of ints, because remember, an array is a type. So even though it's primitive int, it's an array, so we can treat it as a type, and then we can print out the length of that. And then if it's something other than that, we print out whatever the toString method returns from the object itself. So it allows us to now switch on the type and also provide a variable. So in the case of string, we've got S, color, we've got C, int, we've got IA, and then we can reference that in the right-hand side of our case statement, the arrow, and we can say, okay, this is what we want to do. So we're going to do that, and that will work. So here we're using the switch statement. So we're using the kind of combination of the switch expression syntax with using the arrow that we had, but we're not returning a value, so it's not an expression. We're just saying I want to print out something for each of those types. A couple of things that we need to be aware of with this. First is completeness. If we have something like this, this won't compile because we're passing in object O, and then we're switching and we're saying case string do this, case integer do this. What happens if it's something else? Because we could have many other types that could be a subclass of object, we don't have a complete list of objects that we can deal with, so that won't compile. The compiler will reject that. What we need to do is add a default statement and say, if it's not a string, if it's not an integer, anything else will do this. We'll print out the some other type. So that's completeness. Now, completeness will work if we then combine that with our sealed classes that we had before. So we use the previous example of our shape class, which is sealed and having 3 subclasses. Now what we can do is we can say type tester on shape We can switch on shape, and we know that there's only 3 possible subclasses, which is triangle, square, and pentagon. Now, I'm looking at that code myself, and I'm thinking to myself, what happens if it's a null? But I'm not quite sure. So is it truly complete? I'll have to go back and check that. But in terms of the types, yes, you can use triangle, square, and pentagon. You do not need a default because there are no other possibilities in terms of the types. Guarded patterns. Again, this is sort of similar to what we saw with the pattern matching on instance of, where we can have both the test, the pattern matching on the type, and we can have a conditional and expression, which allows us to test using that value when we've identified it as a particular type. In this case here, we've got our shape again, and we have 2 cases which refer to a triangle. The first of those is guarded by saying if it's triangle T, then we've got the AND operator, and we say and the area of T from our method that we've provided is greater than 25, then we print out it's a big triangle. If that fails the test, we then drop down to the next case and we say, is it a triangle T, but we know it's going to be less than 26 in terms of its size, so we say it's a small triangle. So we can do 2 different things there with a guarded pattern, and then obviously square and pentagon are the same. So the syntax of this is that you have the primary pattern on the type, and then you have an and a conditional and expression. A few things about compatibility issues. Since JDK 9, we've started removing things from the JDK as well as adding them. And that can have an impact. If you're looking to migrate applications from JDK 11 to JDK 17, then these are the things you need to be aware of. First of those is JDK 14. They actually removed the CMS garbage collector. Really not many people are still using that. Everybody should have switched to G1, which has been the default for quite a long time now. And so that shouldn't be a problem for many people. It's an easy command line change if you really need to. Nashorn scripting engine got removed from JDK 15. Again, I don't think many people really use that. The idea of running JavaScript from Java, never did quite understand what the benefit of that was. I did this presentation a couple of weeks ago at a real conference in Poland, and I asked the audience who had used Nashorn as a JavaScript engine, and not a single person put their hand up. JDK 17, they removed the experimental AOT and JIT compilers. This is sort of the Graal stuff that they had. So the Graal JIT compiler, which is a JIT compiler written in Java. Not many people seem to like that. They didn't seem to be adopting it. So the developers said, okay, we're going to remove it. If people are interested in that kind of thing, go and use Graal rather than Hotspot. And then one thing to mention is in JDK 17, although they haven't removed it yet, they said they're going to deprecate the security manager for removal. And the important thing about this is it doesn't make Java less secure. Even though we're removing the security manager, it doesn't really have a huge impact. The security manager in this case is more to do with applets and the idea of the sandbox and controlling access to things outside of the sandbox, such as file access or network access and things like that. So it's something that's very, very old and isn't a core part of the Java security that you need to worry about. One other thing is internal JDK APIs. Again, if we go back to JDK 9, the idea was to encapsulate the internal APIs of the JDK itself. That wasn't going to work because too many people had used them and it would break way too much code that existed already. So they introduced this illegal access flag, which had 4 different values that you could specify with it. And by default in JDK 9, the value of the flag was allow, which meant that you could still access all of the internal APIs without any problem. JDK 16, they changed the default value for the illegal access flag from allow to deny. So it meant that by default, you wouldn't get access to the internal APIs, but if you needed to, you could just turn the flag around and specify it as allow, and off you go. JDK 17, it now doesn't do anything. So even if you try and turn those things back on again, they're not available. Now, that still doesn't mean that all of the internal APIs have gone away. There are 9 critical internal APIs that are still accessible from JDK 17. So it doesn't have any effect on that. So things like SunMISC unsafe, it's still there, it's still accessible, you can still use it, even though you're not supposed to. Just to summarize then, so I will mention a little bit about what we do at Azul in terms of our builds of OpenJDK. So we have what's called Azul Zulu, rebranded a little bit to what's called Platform Core. Platform Core is the commercial support for Zulu. So we're still providing Zulu builds free for download from our website, but if you want commercial support for that with the updates and the both security version and the full version and things like that, then you can have a look at our website for that. Our builds are TCK tested. We have support going all the way back to JDK 6. So we have 6, 7, 8, 11, 13 and 15, which are our medium-term support builds, because we thought 3 years between long-term support releases, maybe people would want to deploy some versions in production. So we're offering 13 and 15 with extended updates. Wide platform support, so the usual flavors, 64-bit Windows, Mac, Linux, and also 32-bit versions on Windows and Linux for the diehards who are just not prepared to give up things like Windows XP. Very much drop-in replacement for the Oracle JDK. You just literally install it, change your Java home, your path, and off you go. Had lots of customers do this, never had any problems with it. To conclude then, the 6-month release cycle, like I said, I think is working really well. We're seeing lots of features come through. The fact that we can have preview features, we can have incubator modules, so people can provide feedback on that. Lots of nice little features that make life easier for developers. There's lots of other stuff I haven't had time to cover in this. There's a whole bunch of other APIs, things like the foreign memory access API, the foreign function API, which is part of Panama, a replacement for JNI. There's a whole bunch of JVM specific things that are in the various releases. And yes, please do check out fujay.io. This presentation is part of what we're doing as a sort of Fujay jug tour, a virtual jug tour. Fujay.io is a website that we started it, but not as a website that we own. So it's independent from us. We're just sort of providing some of the infrastructure and getting it started. And we're working with people like JFrog, who you heard from earlier on. They're one of our partners there. There's people like Pyara and a number of other sort of organizations are involved in this. And it's really about trying to pull together a lot of information about Java in an easy to access sort of form. So if you're looking for things like details of all the command line flags that are available, that's all on Fujay. If you're looking for details of all the different things that are in the different versions, that's all there. There's lots of blogs and stuff like that. So it's a really wonderful sort of set of information on Java. If you're looking for anything about that, have a look at that. And that's it. So I'm going to throw it open to questions now.
Hi, this is Pete. Small question. When we talk about the changes that you see in Java going forward, and we're talking about like the Grail VM and Micronaut and all these things, how do you think that these things might or might not collide with each other to ensure that we keep on getting features going forward, but that we come up with some balance between latency and memory as startup and runtime, and then especially getting features that are meaningful to the general community, because we're still seeing too much of an explosion in my mind. It's coming too fast, too quick to adopt to ensure that we have a stable, correct, supported version. Now, I know that we're running Java 8 and Java 11 for long-term support, but I see there's a lot of needs for things like Spring Boot, Quarkus, all these thoughts. I need your thoughts personally.
Yeah, this is always a tough thing to approach. If you're the maintainer like Oracle are of a platform like Java, and the difficulty is that you need to balance the needs of different users. So clearly there are a lot of users who want new features delivered quite quickly. So the 6-month release cycle is very good for that. But then you've also got a large base of installed users who don't want to change their JDK every 6 months in order to keep up with the latest security patches and bug fixes, which is why we have the long-term support releases. And those are 3 years apart to give people plenty of time to continue using those versions. And in fact, it's not even really 3 years, that's 3 years between long-term support releases. It's depending on who you get your distribution from, it can be 8-9 years of extended support for those things. So there's clearly a requirement to try and balance that. And I think that using that 6-month release cycle is working very well in that respect as well, not just in delivering things. Because what it allows people to do is to say, okay, let's say you made the move to JDK 11 and you got that as a long-term support release. Now we get 12, 13, 14, 15, so on. What you can do is you can take some time out and you can say, let's have a look at 12, let's have a look at 13. Let's test our application with it just to see whether there's any problems with our application. Still in production, still using 11. We've got our security updates, bug fixes, that's great. Then when you get to 17, rather than having 3 years worth of changes to suddenly drop in and go, okay, what do we do with all this stuff? You've kind of gone through a more incremental approach to understanding what are the changes happening. So when you get to 17, really what you're doing is only dealing with 6 months worth of changes rather than 3 years worth of changes if you migrate from 11 to 17. So I think that's sort of, it's a really good way of addressing the needs of two very orthogonal audiences from that point of view. Now, coming back to the sort of first part of that question where you talked about Graal specifically and how that sort of relates to startup time and what's happening in terms of Java. There's a number of things that are happening there. So there is a project that's supposed to be starting under OpenJDK called Laden, and that was intended to look at the problems of startup time and footprint, so that if you're using microservices and you want that, like Graal does with native images, so you've got smaller footprint, you've got fast startup time. Maybe they could do something with that. That doesn't seem to be going anywhere at the moment. I haven't even seen a repository started. There's no mailing list for that, even though it's been a good year since they said they were going to start this up. But alternatively, there's other things that are going on because it's open source. And one of the things that we at Azul have been working on is a thing called Crack, Java on Crack, which actually means coordinated restore at checkpoint. The idea being that you run your application and then you take a snapshot of the running application so that if you want to start it up again, you can literally start it from the exact point where you took that snapshot. There's a lot of complexity in trying to make that work because, of course, if you've got files open, if you've got network connections open, you can't just restart, take it to another machine or start it a day later and expect things to be exactly the same. So this is the whole idea of coordinated, is to allow an application to be aware of the fact that it wants to take a snapshot. So it tidies things up and closes network connections or files, make sure it's in a state where it can be snapshotted, take the snapshot, and then when it starts up again, it knows that it's just been restarted. So if it needs to do things like opening files up again and making network connections, it can deal with that. So there's quite a lot of complexity, but it has the potential to really address a lot of the requirements that people have in terms of microservices. So fast startup, without the problem of the whole warm-up thing that you get with the JIT compiler. You just suddenly go into a running application and you get great performance from it. Doesn't necessarily address all of the footprint issues that you would get with where Graal uses its native image, but it's sort of a different approach to doing things. So there's a lot of work going on in that space to look at how to improve things. Yeah, I think that's probably the best answer to that.
Do you think they'll have a tech preview for what you just discussed of like a snapshot?
Yeah, we have a proof of concept. We've literally in the last few, it was probably 2 or 3 weeks, we put a proposal into OpenJDK because we'd done this work internally ourselves. We put a proposal into the OpenJDK to start a new project to explore this further and potentially bring it into the mainstream OpenJDK project. So if you look up on OpenJDK, there is a project called Crack, CRAC, And we've got some stuff there that you can look at. There's a GitHub repository that you can download stuff from. And we've done, so, like I said, some proof of concept stuff and testing. So maybe at some point that will make it into OpenJDK.
That has a lot of promise when you think about serverless ideas like
Yes.
EC2 versus ECS or Lambda, or these types of concepts, because this is the bane that I'm seeing in the industry right now that is so on spot that they just want to save money. They don't care. They just want to save money. And this is all the whole drive for these things of serverless.
Yeah, I mean, I absolutely understand that. I guess the thing I would say is that serverless isn't the sort of panacea. It isn't the answer to everything. So there are definitely places where serverless is going to work really well for certain types of applications. But if you think of many applications, microservices, micro is a really bad word for microservices, because it should be like uniservice, meaning it do one thing, do it well, rather than make it really, really small. So yeah, serverless is a good thing for certain types of applications. But if you look at a lot of microservice architectures, there are still some pretty big chunks of code that are executing for long periods of time. And it's the benefit of being able to spin up more instances to address load balancing and stuff like that.
Yeah, I agree with what you're saying, because really there is not an adequate definition to really say this is good microservices, or this is bad microservices.
Yeah.
Because honestly, most of the people are still creating monoliths when they go to these types of designs again. And this is the trap that I see people are getting into, because they're not like separating their data state concerns to the microservices that they're creating. And therefore they're still sharing the same state database for all these microservices that sit on top of the thing.
Yeah.
And so it's still that monolith. We're back to the monolith.
Yes. Oh yeah, I agree with you. I've seen a number of examples of that, and I've done a bunch of presentations on microservices, and it's always interesting to poll the audience to ask, how many microservices typically do you have in an application? And you get people who've got like 3 microservices. It's like, okay, that's pretty much a monolith, isn't it? And then you've got other people who've got like 100 microservices, and you think, okay, that's probably a little too fine-grained. Obviously depends on what you're doing as an application, but once you start getting up to that really large number, then trying to manage that and coordinate it and orchestrate it becomes, you're just shifting the difficulty and the complexity to a different place.
Well, I agree with that, because when I was working for one group and I was trying to get them to think about these things, and giving the small example that I just gave you, they wanted to shift totally from microservices to Lambda, still with a monolithic database behind the scenes. But they were going to take, because let's say Lambda, you're going to use Lambda. Lambda really does not intrinsically have an HTTP context associated with it, because you're only creating a function.
Yep.
In order to break this down, they took authentication. They were going to have to create 25 unique functions just to break up authentication into this, because they had to change password, create user, all the different things of the business of adding someone to the system. And therefore they didn't understand what they were doing. And this is why I could not see this working for them.
Yeah, I agree. We've got a square hole, we've got a round piece of wood, we're going to just push that in there and we're going to make it work.
But crack might actually help, because
yes,
if you think about these things, I think you would be able to efficiently create a Java microservice, however it is, even if it's monolithic. Therefore, it would get into that good billing sweet spot to start up very fast with low latency. You might have too much memory associated with it, and therefore you'll have the same state that you left with, but that's fine.
Yes.
I had a question about Docker. So in Java 11, we got a lot of goodies with fixing the kind of default behavior of memory allocation, because it would, Java would assume it had the whole machine. It wouldn't look at the Docker container, and now it does. Did Java 17, between 11 and 17, did we get more Docker awareness of any kind, or thread management or anything like that that's going to help us?
I'm trying to think, because I know that, as you say, earlier versions, they actually made the JVM container aware so that they would understand that there was limitations on the number of cores and limitations on the amount of memory, so that it would set things correctly on that. I'm trying to remember. I think there was one thing I remember seeing that was related to Docker, but I honestly, off the top of my head, I can't remember what it was. But I don't remember it being a particularly big thing. Once the JVM is container aware, there's not a huge amount that it needs to do differently that it would do if it's not running in a container, if you see what I mean.
Yeah, that makes sense. It is definitely a selling point that I use to get people off of Java 8.
Mm-hmm. Yes.
I was like, hey, we're already doing Docker in the cloud. Please stop using Java 8. Let's use Java 11 and get rid of all these. You just basically had to like set a lot of XX parameters. Yeah. Lots and lots of them. And then if you changed the container, you had to then go back and change the XX parameters again.
Yeah. So one thing that I can add here real quickly is the fact, like, if you go to Java 11 versus Java 8 for a Docker container, because you don't want to run it as root, therefore you have to create your own C group inside of your own container, groups and users and all these things, and create your own authority. And therefore, when you do this, Java 11 supports this much better than 8. And therefore, I think it would help you as selling that.
Right. Yeah. So yeah, that also I had another question, if I may.
Sure. Yeah.
I noticed that like I hadn't seen the new switch construct in the latest in Java 17. It looks like that's I did Scala back in the day, and it looks like they're borrowing a lot from Scala, which Scala did a lot of years of kind of refinement on their syntax and whatnot. I assume that had some influence. Is that an active interchange between those folks?
I'm not sure. It's a little hard for me to answer that question definitively, because I no longer work for Oracle, so I'm not quite as embedded in the decisions that are made about how things get added. But yes, I mean, one of the great things about the architects of the JDK, people like Brian Gertz, Mark Reinhold, John Rose, and so on, they're very happy to look outside of the Java ecosystem and say, okay, Python has a way of doing text blocks. People know how to use that. It works really well. Let's use that in Java. They've taken things from Kotlin. They've taken things from Scala, as you say. It's about looking around for things that make the job of Java developers easier. And I remember that, James Gosling, the father of Java, one of the things that he said very early on was he considered Java to be a blue-collar programming language. It wasn't an academic exercise. It was about writing a language that got the job done, and so you could get your work done as easily as possible and as reliably as possible. So I think the architects of the JDK have really kind of stuck true to that by just adding things that make developers' lives easier, without necessarily, putting in academic ideas and stuff like that. And if you look at some of the bigger projects, I mean, things like Project Loom for the fibers or virtual threads, so that you can get massively more threading in a Java application. Valhalla with the idea of value types and things like that. But there's some very good ideas that are coming that will move Java forward even further. But yeah, they're very happy to kind of look around and say, what are people using in other languages? Let's take those ideas. Because really, if you go right back to the beginning of Java, it was based primarily on C as the syntax.
Yeah, exactly. That's a good way to put it. And please thank anybody you see and is responsible for the text blocks.
I will. Yes.
Using shell programming even in the 1990s, to do things like write a long SQL statement or an XML block. Had done that, and then having it finally in Java has been it's been a pain for years, but I'm glad we finally have it now.
It's funny because like if you look at the features that have been added between 11 and 17, the one that always sticks out to me as the best feature for developers is records, because it's the simplified data types. But text blocks is one that lots and lots of people say to me, oh yeah, that's great, you know, we really like text blocks, and you wouldn't immediately think that's going to be the best feature, but it's something that should have been in Java a long time ago.
Yeah, I do remember the promise. Somebody, probably on Oracle or even the Sun staff back in Java 8, they were trying to get it in Java 7 and Java 8, and it missed for reasons.
Yes.
And
yeah,
it's finally here.
Yes.
I was going to ask a question. You were talking about, if I understood correctly, you're talking about saving the state of a running Java application, and that got me into the mind. Instead of asking the question, when the JIT compiler runs, does it consider the data that's been seen so far, the arguments and calls it's seen so far, or does it do a generic optimization?
Oh no, the JIT compiler will base its decisions about optimization almost entirely on the recorded profiling data of that running application. That's where you end up getting a lot better performance by using a JIT compiler, because the JIT compiler can use speculative optimizations. What we've done in terms of the analysis we've done is that over 50% of the improvement in performance we get through our JIT compiler is through speculative optimizations. And that's where if you've got a piece of code where you got an if statement, and you look at the profiling data, you only ever go through the true branch of that if statement, then you optimize out the false branch, and you can do some quite clever things with that. So things like that are really, really powerful as optimization techniques, and the JIT compiler will definitely use that profiling information to figure out where to make those things. We have a different approach. There's a different technology we have for our Zing or Prime JVM, which is called Ready Now. And it's kind of the same idea of taking a snapshot, but rather than taking the whole state of a running application, it looks more at the JIT compiled code. So it will take a snapshot of all the classes that are currently loaded, all the classes currently initialized, all of the profiling data, and any de-optimizations that happen. Because when you do speculative optimizations, you make an assumption that it's going to hold true in the future, and sometimes it turns out that you do end up going through the false branch of your if statement, and you have to throw away the code that you've compiled and then recompile it. So if you can minimize the number of de-optimizations when you run your application, then that's very powerful as well to kind of improve performance. So there's things like that we do, which is different from the crack approach.
All right, thank you.
I just kind of have an observation. When I was looking at those records and sealed classes in combination with pattern matching for switch statements and instance of and so forth, it almost looks like it goes back to what you see in a lot of functional languages. It's called generalized algebraic data types.
Yes.
Where you have the records being the conjunction, I guess, and the seal classes representing disjunction. It just seems to be a much more verbose way of saying it than in languages other than compared to, say, Haskell, where it looks like it's almost borrowed from. But it's essentially the same concept. We just got to express it in a more Java-like way.
Yes, and I think that if you look at certainly like people like Mark Reinhold, I know from talking to him that he has a strong background in Haskell, so he probably is bringing some of that idea into that. And if you look at the plans for, like you said, with the combination of records and pattern matching, there's more that will come in 18 and probably even 19, where they'll go further with the pattern matching stuff. So it's not the end of that yet. So there's some really quite interesting ideas coming up. But like you say, it starts to kind of almost change the syntax a bit. It's kind of like when we had streams and lambdas, where we got that initial idea of functional programming in Java, but you had to do it in a Java way, like you said.
Right.
And we're seeing a bit more of that, where to start with, the syntax is going to feel a bit unfamiliar and a bit scary, but then once you get used to it, you go, wow, this is really powerful. I really like this.
Right. It just seems like so many languages are just stealing from Haskell these days. It's like that's where it seems to be coming from. I had another question too. Is there going to be any work done in the language or the JVM to try to close the gap between the distinction between an object and one of the built-in types? You know how we have the wrapper types, right? Integer spelled out versus int. And that creates a problem when you try to do generics. You can't have a generic int, just int. You have to do all this boxing and unboxing for types. And that can create problems with collection types because you can't have generic on like just, you know, one of the built-ins.
Yes, and the answer to that is yes. It's called Project Valhalla.
Okay.
So there's two parts to Project Valhalla. One is value types, which is simplifying the way that storage works underneath, and the second thing is the idea of being able to do generics based on primitives as well as on object types. So yeah, you won't actually do it in this way, but you could effectively do, you know, list of type int. The syntax will be a little bit different to using just the primitive on its own, but there's a lot of work going on that at the moment. In fact, if you look at, I think it was Jdk 16, one of the things that they did was they had to do a little bit of preparation work for Valhalla. They deprecated the constructors on the wrapper classes so that you couldn't use those anymore, because that makes it easier for them to do that. They also, in Jdk 16, I think you no longer can lock on a primitive wrapper. So there's a couple of things that they've done there which are fairly minor changes, but it's leading towards something that will come in the future, which is, as you said, the ability to have a collection where you don't have to do the boxing and unboxing and all of the garbage collection and stuff like that.
Okay. Do you expect to see performance benefits when you can get rid of that?
Yes.
I would think they could potentially be quite significant.
Yes, that is the whole idea behind that project, is to really radically improve performance of things like that.
When can we expect to see that? is that an 18, 19?
No, it's a bit further away than that, because it's worth looking on the OpenJDK page and reading up on Valhalla. Reading up on Valhalla, because it's such a huge shift in the way that things work more underneath in terms of the VM itself, because it has to do a lot of the storage stuff. That they've, as far as I remember, I think they've been through 3 iterations of how to do this, and they think they've got to a pretty good, stable kind of idea of how to do it. But there's still a lot of work that needs to be done, because obviously what they don't want to do is introduce something and then find that it doesn't really work the way that they hoped it did, and then they've got to like pull it all out and then redo it and stuff like that. So they're taking a very conservative approach to it. I would expect, so 17 is coming out next week. There will be the next LTS release. I would say that you probably see something with Valhalla before the next long-term support release. So I think we're talking 3 years.
3 years before we can really do that.
There'll probably be some bits between then, so you may see something in like 19 or 20. But I think if you wanted, if you're thinking about production, probably by the next long-term support release, you will see some Valhalla stuff.
What's the number of the next long-term support release? Has that been decided yet?
Yes, because it will be 23.
23.
Yeah, 17 plus 6. Yeah, it's every 3 years.
All right. Have you seen any efforts put in, you know, we look at more and more functional programming seems to be finding its way into Java and the JVM environment. The other thing that you end up seeing a lot of is recursion. And whenever you do recursion, there's always the danger that you're going to overflow the stack, right?
Yes.
So you see these optimizations like tail call, elimination, and so forth. And there's been attempts at that, but I don't know that they ever really go anywhere. Do you see anything along those lines?
Nothing that is concrete. Like you said, there's been various attempts at doing that. I know I've seen, you know, bits and pieces about that. People are still looking at it, but I haven't seen anything that's a sort of solid project that I would expect to be delivered into the JDK anytime soon. Yeah,
because that can make it kind of challenging to try to port functional languages to run in a JVM environment. You know, that can make it hard to, I mean, there is EDA, which is an attempt to get a Haskell-like language in, but I don't know that that project is really active anymore. And I noticed, for example, like people who work in Clojure,
Yeah.
you know, they have to do special cases because it's basically Lisp
Yes.
for the JVM.
Yeah.
But, you know, you're doing so much recursion in that that you have to have special cases to be able to handle that so that you don't overflow the stack. That would be useful to have for those functional languages. All right, so does anybody else have any questions? Okay, well, I'm not hearing anything more. Oh, we did have a question in the chat. Weichi was asking there, is Boolean B equal O instance of string S legal there? I think that refers to then what would be the scope of that variable S there you would see there in the chat.
Yep. Oh, okay. If Boolean B equals O instance. No, that I don't think that would compile. Doesn't look like a valid syntax. Because oh, actually, no, hang on. You probably would, yeah, because there's a parenthesized. So you'd probably just have to put brackets around it. So you do, if you did Boolean B equals brackets O instance of string S, that would be legal because it would equate to a Boolean expression. So you could assign the value, but S.
Right. What is the scope of S? I don't know what it would be.
I don't think you would have this. Yeah, I think it would depend on what the rest of the code was as to where you were trying to use S. But the assignment would work. But I don't know, unless you had some more code, whether the scope of S would be valid, because it's not being used at the moment.
Yeah, I don't know if you could really access S in an environment like that.
Yeah.
I guess you can always just kind of experiment and just see what kind of an error the
JShell is your
compiler
friend.
gives you. Okay. All right, any other questions? Okay. Well, hearing none, I'm going to turn off the recording here. Let me push this button.